Nas, welcome to Computing Education Things.
Thank you, Daniel. Thank you for having me here.
Absolutely. So thank you for being here. This is the second episode of the podcast. On the first episode, we focus on a Python library called PyTamaro and how graphics can also be a good domain for programming. It was very interesting. It's already everywhere. You can check it out. And today,
Mhm.
I want to continue talking about teaching with you, Nas, and particularly, particularly, I want to focus the episode in the visualization tools world and how visualization can be applied to learn computing concepts. So, to start with, right, I'm sure there is mm, much more than we know about visualization, because my feeling is that when we talk about visualizations for CS education, for sure it's a misconception, but we tend to think that they are useful because and only because they are visual, they are beautiful or easy to read, right? But in most cases, we don't go further. So
Yeah.
to start the conversation, as maybe you can tell us about, or you can explain us why visualization matters, and how we can approach better this domain in the context of computing education.
Yeah, absolutely. So one of the things I noticed early on as a student is in almost all of my classes, all the instructors were using some kind of visualization. Whether it's like starting by drawing a memory model on the Blackboard, or if it's on the slides, adding visualizations from other places, like for databases courses. And so even from a review that we have in computing education, we do know that almost all instructors use some or the other kind of visualization. And the idea is abstraction, right? Before we start understanding all the details, we need some way to imagine it before we have mental models. But at the same time, there is a lack of consistency. Some people use different types of visuals. We don't have consistent tools. And while we're going towards some consistency in algorithm visualizations because we just have so much work that is done there, we don't have that much consistency with, for example, even intro to programming, because as Sorva talked about in his review, a lot of people just did visualization work, but after graduating from their PhD, they were no longer supporting the tool anymore. So we have some widely used tools that are still supported, like Python Tutor and stuff. But for someone who is completely new to programming, that can be very overwhelming. And then suddenly, as you're taking different courses, people are using different types of visualizations, and it just gets more confusing.
Yeah, and I also think that there are no enough emphasis on on visualization in general in the computer science degrees, right? At least in my case, there was an elective that I didn't take, but it was more about graphics and visualization with a greater focus on computer graphics, right?
Yeah, yeah.
OpenGL, graphic algorithms, and these things. So my feeling is that this visualization subject or course is not mandatory in many ways
Yeah.
and it's not optional. But I don't know, maybe in the University of Toronto, you have a different focus on that.
Yeah, so in at the campus that I was at, data visualization wasn't even offered as a course in computer science. It was a part of some of the other courses that I've taken, but it wasn't a course in itself. Maybe for the stat students it was. Now at the campus where I am, it is offered as an overlap between the stats department and the computer science department, and taking as a graduate student. I think it made me understand how important the topic is because, well, when you use visualizations, the idea is you can see patterns more easily. And so I think it's important to have the knowledge to identify those patterns and not be fooled by some of the graphs that we see. And I think that's also true for the visualizations that we make about computer science topics. Like, we are doing performance testing with CPUs and GPUs. We also have data with looking at debuggers, right? There's so much information that is presented for students. So it's important to have visualizations where they know where to focus as they're going through the code.
Yeah. Yeah, and all the studies are showing that, computing degrees continue to rise, and we find different needs among CS students, different ways to learn. And, it is great that studies like yours, right, exist to confirm that visualization is helpful, right,
Yeah.
for more retention, for more understanding, for more engagement, right? So, so yeah, let's say we understand how visualization helps us learn computer science concepts. Now that we know the benefits, let's talk about teaching, right? Because it's interesting to look at the different categories here. Well, I think you mentioned that on the paper you recently published with your team, that animation and videos are not bad for learning, but they are not the best for teaching how computing concepts work. I understood this well. All
Yes.
right.
So the idea, and this is like, I think the credit for this goes more to the algorithm visualization folks in this space. But the idea is looking at it almost like a taxonomy of how much students are engaging with the visual. Uh, you can also imagine yourself in classes, like looking at it with a traditional class or flipped classroom format. When you're traditionally viewing a video or an animation, you are more passive. And usually when people are more passive, they just try thinking of other things, zoning out, and they're not paying that much attention to it. Whereas when they have some kind of engagement, like being able to control the speed, being able to have disclosure, or even more where they can add their own data in, for example, their own code, or if they are able to draw the visualizations themselves, that's like the highest form of engagement. That might lead to better outcomes because that's how much of their knowledge they're engaging with. Whereas when you're passively giving it to them, they aren't really thinking about the connections themselves.
Yeah, interesting. Very interesting. So let's talk about, different areas here, like concrete areas maybe for applying visualization. So I think there is a great opportunity in algorithms, right? I know this website called algorithmvisualizer.org because, this exercise usually involves multiple steps, right? An algorithm such as bubble sort, for example, can have almost, I don't know, 200, 100 and a half interactions, depending on how large it is. So these kind of environments, I think, helps us to see the process better and also to understand the problem better, right? But we are not just talking about algorithms, right?
Yeah, yeah. Exactly. So as you said, we have resources for algorithms, so many websites online. I think I used to use different websites to see, for example, how a regular expression is working versus looking at, for example, how a binary search algorithm is working or sorting is working. But we don't have that many for other areas of computer science, like, say, executing a database query. There aren't that many publicly available open softwares to do that. Or in networks, I was so confused when I took networks as a course and trying to understand how packet flow is happening. So I would have really appreciated having some kind of simulator visualization that could have really, mapped what I was seeing, because it's so hard sometimes when you're trying to learn what's happening, but trying to create a visual in your head. And as we know from the literature, that often creates incorrect models initially, because as you're new to it and learning more, you might be imagining something that's completely off and relating it to what you know. But as you learn more, you get better. And so having that support earlier on can help students. And I'm hoping we work more on those tools.
Yeah, so let's dive into the SQL and data wall because I think there is a big opportunity there, and in general, because the field of data is immense. So, and I believe
Yeah.
it is one of the areas AI, for example, can have the greatest impact because the entire process has always been tedious and
Yeah.
require a lot of like, cognitive effort, right? So,
Yeah.
for example, SQL formulation, right? You mentioned on the paper the case of SQL or yeah, I think
Yeah.
it's
Yeah.
SQL right?
Yeah.
These visualizations, I'm going to ask you because maybe you know the answer. I mean, these visualizations occur at runtime or like is it an overlay in the program or
Yeah.
how this real feedback works?
Yeah. So I think with SQL Viz, what the authors did was they would, like a student can write a query and they would see in real time what this was querying in the tables. So, what data was being joined together and what subset of the data was coming out. Because when you're working with like lots of tables, it becomes so hard to imagine like how are these tables joining together or how is this where clause working. So the authors in that paper did a great job at kind of integrating the aspects of the query, like what tables they were working with, what columns, and then the subset that was filtered yeah, in real time.
Yeah, okay. Yeah, and yeah, interesting. So yeah, I'm going to share the resource in the description below. So I talk about AI. No, AI question of the day is like I have to ask you about AI. So I use very often cloud artifacts. Cloud
Mhm.
artifacts. Do you recommend AI for designing visualizations or AI helps you to make visualization in a way that promotes understanding and has this impact we've talked about today?
Yeah, so I'm actually working on a project with the JetBrains group at TU Delft with a student, and we're working on videos which kind of use what I've been working on in a separate space. But the videos are generated using a large language model. And then having a voiceover for those videos. So not only are the analogies kind of generated by the large language model, but the voiceover that we've added is also generated by large language models, which kind of helps because now you can personalize the analogy. I think Yuho actually published a paper at ICER last year, which was about that, with personalized analogies. Because when I go to different contexts, these analogies that I'm using in a North American context sometimes don't make sense in some European spaces. And sometimes when I'm talking to some of the men in my computer science classes, they think something is too childish. So maybe they
Mm.
need separate analogies which are not that childish. So I think having the support of an LLM to make those analogies that we're using with the visuals more personalized to the kind of support a learner needs, but also being able to add more modalities like voice, that would be really helpful with AI.
It's interesting. Yeah, we also notice some, for example, we ran a survey this spring at the University of Houston, and we asked questions about vibe coding to male and female, and the answers for this general, you know, theme. They think that vibe coding is positive in some ways and these things, but they also differ in some ways when we talk about entrepreneurial interest. So males have an opinion and females have yeah, different opinions, right? So it's interesting to analyze the gender
Yeah.
differences here. Okay, so in the last episode, Matthias explained to me why graphic design alone is not enough for in this case for graphics programming. Okay, so there also has to be a software engineering component to know how to break down the problem, right?
Yeah.
For example, in introduction to programming, mental models or visual metaphors may not help you write code, but
Yeah.
they give you a vision, right? They give
Yeah.
you a mental map that is very useful to write
Yeah.
the syntax. So what's your opinion there?
Yeah, I think, and it's something that has come up in my own like committee meetings because sometimes you'll have people from who've been programming since the 90s and they don't need that much visual support. They're okay with like when they're working with C programming, just seeing like a stack dump and seeing what variables to see there. They're okay with that. But I think as we're working with newer generations of students, I don't know if this is it's controversial if this is a problem we should be solving or not, but we do know that students are starting to read less and they need more abstracted information just given to them. So I am of the perspective that having visualizations, which at least start training them to see what parts of the program are important, how they're working with each other can be important. And it can help them as they're working with debuggers. I mean, I think I've been struggling so much over the years with like just getting students to see how useful debuggers are. But I think the overwhelming part for them is like just not knowing how to use them and where to focus. So I think it can help not only with mental models, but even, bridging them to using these tools to start seeing what parts to focus on. So like abstracting it so they only have those parts at first, but then letting them see everything on their own and deciding whether they find it useful or not.
Yeah, 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 that makes sense. So moving to the psychological part of the conversation, because I think visualizations can also help a lot to the young people, because we live in a
Yeah.
world full of noise, information everywhere, a lot of, different, like, I don't know, a lot of news, everything. Our attention is constantly being threatened, right? Visualizations can
Yeah.
separate, I think, signal from noise sometimes. I think this constant overstimulation, doesn't help us to focus, right? So, do you think visualizations can also help on that direction?
Yeah, absolutely. I think one of the terms that Katie Cunningham uses in her paper is cognitive offloading. So this idea
Hmm.
that when you're, for example, reading materials and you're trying to make the model in your head, that can be a lot when you're like also trying to absorb new information, but keeping track of old information. And that's where like, for example, cognitive load comes in, where, we can only keep that much information in our working memory at some point. So having visualizations can help offload some of those things so you don't have to keep track of them in your head. And as we move to a place where I think, students are getting more used to the 20-minute TikTok, no, not 20-minute, 20-second TikTok content and stuff with like really having short-term memory. I think we're moving in the direction where we want to offer, or we might want to offer more tools where they can cognitively offload because they're not used to keeping track of that much information.
Yeah, yeah, yeah. Yeah, that's the reality, and we have to adapt to that.
Yeah.
Yeah. So I want to talk about online learning because you also mentioned that on the paper. I believe that teachers still need to make more effort sometimes to achieve more or greater participation and
Yeah.
maintain motivation during online lessons. So I don't know if interactive visualizations can also help to make learning more active, maybe
Yeah.
through online lessons.
Yeah, so the work that's been done there is related to this idea of increasing motivation through storyboarding. That's increasing a lot more. So this idea of encouraging self-regulated learning with people setting goals, showing them how far they've progressed towards those goals, using a storytelling format. And like we spoke about before, they're also starting to incorporate AI there because the issue with large classes is almost none of them get personalized feedback. And, it can be easy to lose that feedback when, like, for example, if I'm working with a one-on-one personal tutor, yeah, will feel like I need to be much more accountable than I will feel like if I'm in a 1,000 student class and no one cares if I drop the course. So the idea there is having some kind of personalization using AI to keep people on track with their goals, checking in, kind of showing them how far they have come in the course and testing their knowledge. So those tools can be very useful there to just show them the progress that they are making.
Yeah, absolutely. So, so in terms of critical thinking, problem solving, I think this point about turning abstract concepts into understandable formats is what resonates with me the most. There are initiatives such as, for example, I'm a big follower of this blog or newsletter called Level Up Coding. I think they do a fantastic job in terms of turning complex concepts into
Yeah.
easy to read visualizations. So I recommend it a lot. So I don't know if you have some examples or some, I don't know, recommendations to turn the abstract concepts into, interesting software engineering concepts or interesting visual explanations.
Yeah, I think that's an interesting question. What I've come across so far with the critical thinking problem solving domain is when we do create those visualizations for students, not only do you want to think about what are we abstracting, so like all the variables that they need to see, the connections between them, but you also want to get them thinking critically. So some of the work that's come in that area is prompting them with questions like, okay, we've presented this visual of the stuff you need to know, but now instead of you just clicking and seeing what happens next, you try to think about this visual, try explaining what you're seeing here, what the next step would be. So in that case, I guess, in addition to this idea of creating a good visualization, there is this responsibility to create questions or points where they are critically, they're prompted to think critically.
So in that case, you mean that the student has to write the prompt, like he has the visualization on the screen and he has to prove prove themselves that I know this, right? Okay.
Yeah, exactly. So, for example, say I'm demonstrating how a linked list traversal works. So, in addition to just showing them, oh, this is how it's traversing through the linked list, having some questions like, oh, what if we had to change this traversal? What if we wanted to delete this node? How would this visualization change? Or what would we do next to the method? So, really getting them to think critically about what they've seen so far and about what a next step could be. That's really important for those.
Yeah, and then Matthias told me in the first episode that he solved that critical thinking question, blur like putting in blur like the in blur, sorry, the the background. So you have to click on one button to and hide or to see the answer. So
Yeah.
basically it forced you to think more critically about the solution. Of course, you can click without thinking, but the thing is like, okay, if I have, so it forced me to think, right? At least you are encouraging to think, and that's the important point here, because we are not only talking about entertaining the student or finding fun ways to show how to learn, but to find ways to that you understand better the concept, and because you finally are going to do an exam or something that you need to pass, right? So it's important not to have fun only, but also to learn.
I'm forgetting what the exact term for it, but I think it comes from one of Vygotsky's papers from the zone of proximal development, where there's this idea that learning happens when there's some difficulty. So the more difficult it is for you to get the answer, the more fulfilled you feel once you get the answer, and the more like you're likely to remember that you got to the answer. But there's also this idea of, oh, if it's too difficult, then they're gonna give up. So trying to find a balance between like not making the question too difficult, but like giving them enough information to make them think of the answer, not just giving them the answer.
Yeah. Okay. So I think my last question, because it's we can spend hours talking because this
Yeah.
theme is very interesting. And but I think it's about diagrams, right? Because diagrams are very useful for demonstrating, I think, what you understand about a problem. But I was thinking before the conversation that if I was, if I am a professor, I could ask, or I could, make this question about a diagram in the exam. I don't know. I would make them mandatory in a programming fundamentals exam. Like before doing the code, you have to draw the diagram. I don't know. What's your take here?
Yeah, so I have definitely seen some of those questions on exams. Um, and we do know that, prompting students to practice diagramming is actually more helpful than just seeing the visuals on screen. But what we also know is that it's a huge learning curve to be able to construct those visuals. I think in the engagement section, being able to present what you're talking about, the problem you're solving, is one of the highest forms of engagement because you're really incorporating everything together. So I think it's a very promising thing to do. And I do think from the literature that we know it's valuable. But what I am concerned about is whether students are getting enough practice with it, which is why I work with interactive visuals, right? Because if they aren't practicing it so much in class, you then have this idea that, oh, like we talked about the zone of proximal development before, they're more likely to give up or feel bad because it feels too difficult for them. So I think they need more tools at first to start seeing how the diagrams are done. One problem I've also noticed is sometimes instructors are too detailed with the diagrams and students feel like they're tight on time to draw. Like for example, if you make a memory model, you can make it as detailed as you wanted to account for everything. But is that a diagram that students typically imagine as they're working through a problem, or are they imagining a more simpler version? And the question I have is then, should we be making them draw these complex diagrams, or should we instead spend more time practicing diagrams that they might use in day-to-day life?
Yeah, yeah, awesome. So from these last words, I got that we need to make more visualization tools. So we have to
Yeah.
encourage everyone here that you have to develop more, right, visualization tools
Yeah.
to contribute to this computing education field. And I think, well, I'll put all the links to contact you in the description. And I think we can leave it here.
Thank you so
Thank you
much.
very much, Naz, for your time.
Thank you. That was a great conversation, and I really appreciated being able to talk about this. And I wish you the best for other episodes.
Awesome, awesome. Goodbye, everyone. See you in the next episode of Computing Education Things.